Honors Geometry students, welcome back. I feel like it's been a while. So in this lesson, and I already see a spelling error, of course, you're going to be using knowledge of algebraic operations and equations to successfully solve proportions for a missing variable. So a lot of what we're going to do in this lesson is going to actually be algebra review, and towards the end of the lesson, I am going to show and explain exactly how this ties in with what we're learning. And some of you guys might and hopefully do recognize this word from recent times, right? Like we've been maybe saying the word proportional as we've been speaking about, I'm having trouble writing, as we've been speaking about dilations, right? And how when you're dilating things on a grid, everything is happening proportionally. Like all of the sides are becoming double. Like every single vertex is becoming 3 times as far or a quarter of as far from the center of dilation, right? So there's that word proportional. So hopefully, I know many of you guys like to print out the PDF of the video lesson. So hopefully you either have that printed out or you have your notebook ready to go to write down some notes so that you can use them when you're working on your homework. Okay, so what I want to first talk about is what exactly is a ratio, right? So maybe you know or you've had some background information or knowledge about what exactly a ratio is, but a ratio is a comparison of 2 values expressed as a quotient. Well, what's quotient? What does that word mean? The quotient is the answer when you divide, right? So the quotient of 4 and 2 is 2. This number right here is the quotient, right? The quotient of 10 and 2 is 5. Why does this not want to write? Okay, so I want to show you guys while I have you here a brief video that I thought was pretty cute and pretty good. And I don't know why I just said that, but my computer's like possessed. Oh, there it is. Okay. Pretty good at explaining this concept. So this is about a 2-minute video, 2 minutes and 37 seconds.
This is you, and ratios are everywhere. Sure they are. That's a ratio. 2 bags are 1 bag. 4 bags are 2 bags. 12 bags and 6 bags.
Okay, so hopefully that gave you a giggle. It made me laugh. So as you can tell, like we're really just comparing two values, right? And that's what a ratio is. So maybe you can think of something that we've been talking about that really is a ratio. Was anyone thinking scale factor? And then pretend that you're all answering and you're like, that's what I was thinking, right? Scale factor, that's a ratio, right? When we're saying the scale factor is 2/3, well, the ratio of the new one to the old one is 2:3, right? That's what a ratio is. So when we take this a step further and we talk about proportions, a proportion is an equation stating that two ratios are equal, right? So a proportion is an equality of ratios. A to B equals C to D. So if you're thinking about maybe the pictures that we've graphed a little bit, well, let's say the side of a triangle is, one of them is 2, and then it gets dilated and it becomes 6. The other one started as 4, it gets dilated, and what does it become? Well, I'm multiplying by 3, so it becomes 12, right? These are equivalent ratios. They're equivalent. They are both equal. In fact, they're both just equal to 1/3. Right? It's just saying like maybe we have a different starting value. Okay, so that's what a proportion is. So what we're going to talk about is how we kind of tie some algebra into this, which we really have been, and actually use this idea of proportions, which are two equal ratios, and that's important to know that they're equal to each other. And think we're talking about corresponding, right? 2 corresponds to the 4. If we're talking about two shapes that were dilated, if this side was 2 and now it's 4, oh gosh, why is this so difficult? And this was 6 and now it's 12. These sides are corresponding, even though they're not congruent, they're corresponding sides, right? So using that to set it up. So let's try some. And maybe this is something you already know how to do. So our goal here is to solve for x. If I want to solve for n, sorry, I said x, but n in this case, there's a few ways I could do this. Maybe your first thought, and remember we want to use inverse operations, meaning the opposite operation, operations. So if I see division, I'm going to use multiplication. Oh, I shouldn't have started that with that one. If I see multiplication, I'm going to use division. If I see addition, I'm going to use subtraction, right? Those are inverse operations. If I see something being squared, I'm going to take the square root. Ooh, we did that recently with the Pythagorean theorem, didn't we? So that being said, I see n divided by 10 and I want to get rid of that 10. I'm going to go ahead and, why does this have to be so difficult? Multiply both sides by 10. I'm going to actually do this without even picking up a calculator, and you all can too. Oh boy. I'm having some new computer problems right now. That's why the last video I recorded, I didn't even use a flip chart because it doesn't work as well on my new computer. I don't know that you guys needed to know that, but at least you know why I'm having some trouble. So this is actually going to give me 100 over 8. This is like 10 over 1, so you're multiplying straight across. And then we've isolated n. I can simplify this a little bit. They're both divisible by 4. Oh, it's like having 100 pennies or having $1 and you divide it in 4 quarters. Oh, I get 25 over 2 equals n. If you wanted to say 12.5, that would be acceptable as well. So this is a little curious. I actually didn't use any new method, right? I didn't use anything different than maybe you would have thought to use. Why? I just want that pink. I wonder if you guys can see me clicking on it. I wonder if it changed. It might have. All right, so I'm going to do the same thing over here, right? I'm going to multiply it by 3. multiply by 3. So multiply straight across. This is like 3 over 1. So that's 21 over 5 equals x. And again, I'm just going to leave it like that. I'm not going to touch it. I could if I really wanted. I don't really want to. That's an extra step and something that takes time. But if you really wanted to go with 4.2 because your calculator told you that, awesome. That's fine as well. So I want to ask you all a question. What if I hadn't what if I had said something like 7 over 5 equals 3 over x? I can't multiply by 3, right? I see division, but I'm not dividing by the number I'm trying to get rid of. So this gets a little bit more complicated, right? I don't really know what to do. I want this fraction gone is really what I want, right? I can actually get rid of the fraction by multiplying everything by x and everything by 5. That's cross multiplying. So maybe that sounds familiar. So this is only going to work if you have proportions. And so it's kind of like a shortcut. It's basically saying I'm multiplying both sides by x and I'm multiplying both sides by 5. When I do that, there's no longer going to be an x over here. And so I'm just going to have 3 times 5 is 15. 7 times x is 7x. And now I've gotten rid of the fraction, right? In just that step. And so my next step, I now see multiplication. Now I'm going to do division. And now I just do what I know from algebra, what algebra has taught me. And I would have 15 sevenths, right? It was a different question. That's why it has a different answer. Okay, different question. I could have used this idea of cross multiplication, cross multiply, in order to solve this one as well, right? I could have gone like this. 7 times 3 is 21 equals 5 times x is 5x, and then divide by 5. I actually have one extra step if I do that, but if you want to stay consistent, go for it. But cross multiplying is really what we're going to focus on when we're dealing with proportions, when we have two ratios that are equal to each other. Let's amp it up a little. Let's try these out. And so what I would really love for you to do with 3, 4, 5, and 6 is if you're ready to give it a try, amazing. If you want to watch me do 2 of them and then try 2 on your own, or 1 of them and then try 2 on your whatever, factory 1, you would have 3. That's great, okay? So I'm going to go ahead and use the same method that I just talked about. I'm going to cross multiply. So I'm going to do 5 times 9 is 45. And then I'm going to do 6, and I'm going to write it out. 7n plus 9. The reason I'm going to write it out is I want to be careful that I'm not just multiplying the 6 by just the first term. It has to get distributed. You guys have done a lot of work with the distributed property, and it's been great. We've seen a lot of awesome things with it. Plus, what is that, 56? 54. Go ahead and subtract 54, subtract 54. What do we get when we do 45 minus 54? I get negative 9. Negative 9 equals 42n. And then I will go ahead and divide both sides by 42. So I end up with n equals negative 9 over 42. I certainly hope I did that correctly. Yeah. Right? And if I want to divide that, sure, I can. Oh, it gives me a nasty number. Let's not. It gives me an irrational number. Let's just leave it. We don't need to take the time to try to round it. And if you would really like to go ahead and plug that back in, you can. I could do 7 times negative 9 over 42 plus 9. I get 7.5. 7.5 over 9. I get 0.83 repeating. And if I do 5/6, I also get 0.83 repeating. Right? So I could just check it in my calculator. Don't be afraid of fractions. If you can handle a fraction, you can handle one that's not a fraction, right? So if you can challenge yourself now and stretch that understanding now, you are in a great place. So let's go ahead and do the same thing here. So I'm going to go ahead and do 10 times b plus 5. If I wrote down the 7 times, like if I flipped this side and I had the 6 times 7 n plus 9 on the left, that would have been absolutely perfect too, okay? Equals 7 times 5, which is 35. I'm going to go ahead and distribute that 10. So I've got 10b plus 50 equals 35. And now I've got a two-step equation, which you guys have been doing for many years now. If I subtract the 50, 35 minus, remember, inverse operations, opposite operations, 35 minus 50 gives me negative 15. And when I go ahead and divide by 10, I've got b equals to, let's see, they're both divisible by, that's a 15. They're both divisible by, I can divide them both by 5, and I would have negative 3 halves. Okay. If you want to write that as a decimal, it would be negative 1.5, which is fine as well. Sorry, I'm struggling. Awesome. If you haven't thought about pausing the video, please do. I hope you're still there. 5 and 6 looks interesting. I have an R in 2 places and a K in 2 places. It's okay. Let's do the same thing. So 5 times R plus 5 cross multiply equals to 8 times R minus 9. Just remember that cross multiplying only works when I have a proportion, meaning I have 2 fractions or ratios that are equal to each other. Let's go ahead and distribute that 5, and that gives me 5R plus 25 equals to 8R minus 72. And that's why I like to write it out so I don't forget to distribute. I sometimes forget that, so that's why I'm showing it that way. So I'm going to go ahead and I'm going to add the 72. So that would give me 5R equals 25 plus 72 gives me 97 equals 8R. I'm going to subtract the 5R, so I'm combining like terms right now, which would give me 3R, and then I'm going to go ahead and divide by 3 to isolate the R. So R equals 97 divided by 3, which is an ugly number. It's 32 and a third, 32.3 repeating. I'm just going to leave it as 97 thirds. Saves me time, exact answer. All the things we like. And finally, well, not finally, but finally for this page, and for real, my friends, if you have not stopped the video to try one, please, please just do it. You can do it. You can at least try it. So cross multiply, I've got 9K equals to 6 parentheses K minus 7. 9K equals 6K minus 42. I'm going to subtract 6K, and that's going to give me 3K equals, just be careful you don't drop the negative. Divide by 3, and that's going to give me what? What's negative 42 divided by 3? Oh, gives me negative 14. Finally, one that's nice. Right? So this is really where we want you guys to be. This is what we want you to be able to do. We want you to know and be able to do. I am going to extend it a little bit with a challenge, and you do have a few challenge ones on your homework, and they're called challenge for a reason. They are challenging, and that's okay. I see X in a lot of places for number 7, a lot of places for number 7, and 2 places for number 8. I'm going to start it off, and I'm going to do the same thing I have done. Okay, so I've got X minus 3 times X minus 6 equals 2X. I'm hoping, and I'm disappointed I can't actually see your reactions, that this looks familiar to us from Algebra 1, right? This right here, I have a binomial, something with 2 terms, times another binomial, something with 2 terms. And what happens here is you're going to do the distributive property again. But I have 2 things that I'm distributing, right? I have to distribute that X, and I have to distribute that negative 3, right? So it's a little bit more. You might remember this as FOIL, right? FOIL is not what you're doing. FOIL is an acronym to help you remember double distribution. So I'm going to go ahead and do double distribution, and maybe I'll use FOIL, right? FOIL stood for first. I'm going to multiply the first two terms. X times x gives me x squared. O stands for outer. I'm going to multiply the two outside terms. So x times -6 gives me -6x. I stands for inner, the two that are inside, closest to each other, and I have arrows drawn here, -3x. And then L stands for last, so -3 times -6 gives me +18, and I don't want to forget that I have it equal to 2x. So now I've got x squared minus 9x plus 18 equals 2x. So here's what happens here. When I have this x squared and I have something that on the left, this is a trinomial, I actually am going to have to factor. If you remember learning, and hopefully you have some recollection of this, about quadratics, a quadratic is like, it's like when you graph it, it looks like a U, a parabola. And it has, like, if I were to graph, and I don't actually know where this is right now, I'm not actually graphing it, but it has two places that it goes through the x-axis. It actually, for any horizontal line I draw, it has two solutions or two intercepts. So this could potentially have up to two solutions. So I'm going to have to factor. In order to factor, maybe you remember that it has to be equal to 0. Minus 2x on both sides, minus 2x on both sides. So I've got x squared minus 11x plus 18. And it's okay if this is like, it's called a challenge for a reason, right? So hopefully you're staring at this and you're like, I do remember doing this, but I need some practice with it. And that's a great place to be, okay? So I'm looking for, you guys did something like the AC method, maybe a box method, I don't know, there's lots of different methods. What I'm going to do is I'm going to look for two numbers that multiply to 18, and I want those numbers to sum, add to -11. So the first numbers that come to my mind are 9 and 2. 9 times 2 is 18, but 9 plus 2 is positive 11, so I need to make them both negative. So I've got x minus 9 times x minus 2 equals to 0. And what this I need to now use is something called the zero product property. And that means I'm going to take each one of the factors, the binomials, and set it equal to 0. Because if something multiplies out to be 0, one of the two terms has to equal to 0. So x equals 9. And then if I did x minus 2 equals 0, I get x equals 2. So I actually have two solutions for this. X could have equaled to 9, or x could have equaled to 2. Right, so it's the same process, but I'm bringing in an old skill of factoring. And I'm saying old skill, it might not be something you're super confident with, but I do really want to emphasize that if you're like, I don't think I ever learned this, make a point to come see your teacher and to get some help with this, so that we can build some of these skills. Because this is we are putting this in here because it is very important as we're learning new content to not forget some of the old content. Right? You want to be prepared for algebra 2. So, and then I could plug these back in and check. So yes, this is certainly a challenge. And I don't want to say that it's not a challenge. Okay. So let's go ahead and let's look at number 8. I'm going to start it the same way that I have for all of these problems. Go ahead and cross multiply. I've got x times x squared plus 12 equals -36. Oh, sorry. There's no x squared there, is there? Darn, sorry guys. Just snacks, I was getting ahead of myself. I'm going to go ahead and distribute this. I don't have to doubly distribute, I only have one thing. So fun. X squared, okay, so I've still got a squared, plus 12x equals -36. Okay, so I see an x squared and an x term. My mind automatically should go back here to factor. In order to factor, it has to equal to 0. X squared plus 12x plus 36 equals 0. And I'm going to look for two numbers that multiply to 36, and I want them to add to 12. My mind goes to 6 and 6, the same number. 6 plus 6 is 12. 6 times 6 is 36. So I've got x plus 6 times x plus 6 equals 0. If I wanted to write that as x plus 6 squared, I could have. All right, not a bad idea. And then I can use the zero product property to say x plus 6 equals 0. Therefore, if I was going to solve this, I would get x equals -6, and I would get the same thing for the other one. So I only have one solution for this. Right? My x value in both of these spots, here and here, would have to be -6. What this means when you get a quadratic, and I'm just going to talk about this because, hey, why not? You're going to need this for Algebra 2 anyways. What this means is that if you think about a parabola, this point, that bottom point over here, was called the vertex, and that means that the vertex was at -6, right? Because it only touches the x-axis once. Right? And those pieces, like these comments that I'm making or these other things that I'm kind of bringing up, you don't need to be a master of, right? Like you can be working towards understanding and mastery of factoring, and these comments that I'm making about quadratics, I want to tie it all in, but that's not necessarily what we need you to be able to do right now. We just want you to kind of see where things start to connect and why things are the way they are and why math works and what you could explore and find connections between. So it's always good to hear about and think about. So I am going to tie this in a little bit more with what we've been studying with dilations, but I want to emphasize that these types of problems are ones that are on your homework assignment. And your homework assignment has 3 levels that you're doing. So it has level 1, level 2, level 3. And it does say this in the directions, but level 3 is a challenge. It doesn't mean you can shy away from the challenge. Please try it. But know that it is a challenge. The way your homework assignment is structured is it actually gives you the answers. So it gives you a proportion, it gives you the answer, and your job is to show the work to arrive at that answer. So if your work doesn't make you land on an answer, there's an error in it, and that's okay. Maybe find a way to clearly indicate that or circle it or highlight those on your homework so that we and your teachers can know where the areas are that we need to go back and work more on. So before we finish this up, I do want to talk a little bit more about how it relates. So you guys have been doing stuff like this, right? So you've been looking at dilations and you've done things like, hey, let's go ahead and actually, hey, why not? Let's find the scale factor in the center. So the center, this is getting bigger, right? So I know that oh no, not a quality color for this. Oh, there we go. So I'm going to connect these. It doesn't matter which 2. I could do all 3 if I'm not doing it well. Oh, is the center just 0? That's so fun. Did you sense the sarcasm? So my center is just 0, 0. That's less than fun. And that means all the points were just multiplied, right? So let's go ahead and actually write out some of these side lines. 1, 2, 3, 4, 5, 6, 7, 8. 1. Oh no, is that a partial? It is. It is, isn't it? Let's. Oh, it is. How interesting. I don't know how long this is. I'm going to hold off on that. You know what? I want to count something I can count. Okay. So I think my goal is going to be to figure out what J prime K prime is. And I want to figure out the scale factor to get that. So I'm going to actually just count to get from the center to J. I would have to go, I'm sorry, to J prime. I would have to go left 2. Okay. So I'm going to say that's 2. Oh, sorry. Boy. And then in order to get from the center to J prime, I would have to go left 1, 2. Oh, no, I can't do that either. Sorry. I'm a mess right now. Let's go up instead. I don't know why that was my thought process. To get from the center to J, I have so many different options. I'm going up 1, 2, 3, 4. To get from the center to J prime, I'm going to go up 1, 2, 3, 4, 5, 6, 7. Okay, so remember my ratio is new over old. My scale factor is new over old. So that's 7 over 4. Okay, that's the scale factor. Well, if I want to figure out how long j prime k prime is, well, I'm going to say 7 over 4 equals j prime k prime over 8. Huh. You might see it, right? You might be able to see the relationship. How do you get from 4 to 8? What's this going to be? I could also use what we just talked about, cross multiplying. 7 times 8 gives me 56 equals 4 times j prime k prime. Go ahead and divide by 4, and I'm just going to get 14 equals j prime k prime. Right? So I can use this idea of proportions because I've been working with ratios. I can do this to solve for missing sides. So we're going to actually take these triangles off of the grid and use this concept here to solve for missing sides, right? So for the image to the right, find the length of AC. So if I want to find AC, it doesn't really matter actually which one's new and which one's old, but I'm going to continue with it. 8 over 4, new over old. I'm looking at the parts that correspond. They're not congruent, they correspond. That's why we made such a big deal of that. Equals to 5 over AC. And then I can cross multiply. 8 times AC equals 20. Divide by 8, and I got that AC is 5 halves, or I get 2.5, which you might be able to sometimes recognize, right? Just being intuitive and thinking through it. Well, 8 over 4 is 2, so 5 over what is 2 is really what's happening there, which is great. For this one down here, it says for the image to the left, the scale factor is 1/2. Okay, so the scale factor, new over old, is 1 over 2. Okay, let's see what that's equal to. I'm trying to figure out the value of x. So new is x plus 4 over old is 10. And then we can cross multiply. So 10 equals 2 times x plus 4. I didn't forget my parentheses. 10 equals 2x plus 8. Go ahead and subtract 8, and I'm going to have 2 equals 2x. Therefore, if I divide by 2, x is going to equal to 1. And I could go ahead and plug that back in and make sure, right? Finally, take a moment and see if you can do this one. See how you're doing. We're at the end of our lesson. This is where we're going to finish it up. So I know that this is a dilation, right? I can see that they all originate from the center and it's going through both of those. So this is certainly a dilation, okay? How it's labeled is a dilation. So I know that everything happens proportionally, so I can use proportions to solve this. So it doesn't matter what, I'm going to go with 4x plus 5. What does that correspond with? 2x minus 1 equals 2. Well, if I start with the 4x plus 5, I need to start over here with the 35. If I ever end up multiplying two things that either have a relationship or are on the same triangle, I made an error. Okay, over 15, and then go ahead and cross multiply. 15 times 4x plus 5 equals to 35 times 2x minus 1. Distribute 15 times 4, I get 60x, plus 15 times 5, I get 75, equals 70x minus 35. Okay, so I'm going to go ahead and I'm going to subtract the 60x. Give me 10x minus 35. And then I'm going to go ahead and add 35. So that would give me 110, I believe, equals 10x. Oh, sorry. Divide by 10, and I get 11 equals x. Right, and I can plug it back in and I can make sure that I get the same scale factor as doing 35 over 15. All right, so I talked about what our expectation for your homework is, and hopefully you found this more thorough than maybe the last thing I did for y'all. So in this lesson, using our knowledge of algebraic operations, right, and inverse operations and equations, we successfully solved proportions for missing variables, and we even experienced some challenges which you will continue to work on after this lesson and on the homework as well. And if you need any help or support with any of this, please come come get some help from us. And thanks for watching, and we will see you all next time.